Good afternoon, ladies and gentlemen. Here we go. This is the last section of this unit here. You guys have tests on Monday. Your review has already been released. It was released on Monday. So I would start working on that. You are allowed a note card, of course. It's mostly graphing, plus this little bit of stuff here. There are a lot of weird rules, of course, that Mrs. Wilson here likes to just have you memorize rules, and I really hate that. And so I like things to be a little more thoughtful because, you know, if I give you a rule to memorize, you're going to memorize it for tomorrow and forget it the next day. So what we want to remember is that when we have an arc sine or arc cosine, that arc is telling us to find the angle. What angle has a sine value or a cosine value? Has a sine value of whatever it is, okay? And so with that in mind, as long as you understand, we can always draw it. And that's how I prefer to do these things, okay? So what we have are compositions of trigonometric functions today. And so a composition is that you can see right here on number 1, they are nested, if you will. We have the sine of this whole thing, the sine inverse of -1/3. And I could just tell you to memorize a bunch of stuff, but I'd kind of rather draw it. And I just lost my voice. So what I'm going to do is kind of just show you, and I would draw a little picture here. I'm going to start at number 2. When we have nested functions like this, we have to start on the inside most things. So what I have here is this inside part. And I can draw a picture. Anytime you have an arc function, arc sine, arc cosine, we can actually draw it. This says what angle, so that's what that means, what angle has a cosine ratio of 2/5. And if you remember, cosine, the cosine ratio, SOHCAHTOA, the cosine ratio was adjacent over hypotenuse. You remember that? Okay, so what I'm going to do is I can just draw a little picture. So here is my XY coordinate plane, okay? And it says we have a cosine ratio of 2/5. So I can actually draw that. Well, here is a little angle, and there's an angle theta right there. And I can turn that into a little triangle. And there's my little triangle. And it should have a cosine ratio of 2/5, meaning the adjacent side is 2, and the hypotenuse is 5. All right? So I just drew an angle that has a cosine ratio of 2/5. Does that make sense to you? Okay? There it is. There's that little angle right there, theta. What angle theta? There it is. Okay? Now it's saying, hey, what's the cosine of that angle theta that you just drew? Yeah, it's just 2/5. Adjacent over, it's still just 2/5. Okay? They sort of cancel out. And again, I don't like you to just think, oh, they're going to cancel out. Because is this one going to cancel out? No. Maybe not. But I can know for sure by drawing a picture. Okay? So again, I'm going to start on the inside here. And again, this is cosine inverse, so it's the same thing, arc cosine. So what angle has a cosine ratio of 3/2? So I'm going to draw it. So here's my little XY axis. So I have an angle. There's my angle theta. All right, and I'm going to turn it into a little triangle. And again, the cosine ratio is adjacent over hypotenuse. All right, so then my adjacent side is 3, and my hypotenuse is 2. It's impossible?
But the hypotenuse will be the longest.
This doesn't work, does it? The hypotenuse has to be the longest side. Can our hypotenuse be 2 if one of our sides is 3? Cannot be. This is not possible. Okay? So this is undefined. All right? Doesn't work. And again, if you kind of remember what we did yesterday, this fraction is bigger than 1. All right? Which the cosine curve always oscillates between 1 and -1. And this is 1.5. It's too big. Doesn't work. Okay? But again, we draw the picture and it makes total sense. Okay? Tangent. So again, I'm going to start on the inside here. This is arc tangent. It is negative. And so this is saying, hey, what angle theta has a tangent ratio of -9/2? If it's -9/2, can I draw that in quadrant 1? No, I can't. I have to draw it down here in quadrant 2. So here's my little angle theta. And what's the tangent ratio? Opposite over adjacent. Okay, so the opposite side here, this would be 9 and it's downward. So that's -9. The adjacent side is 2. So there it is. There is my angle theta that has a tangent ratio of -9/2. And so we just drew that. Now it's asking, we go here, the tangent. Well, what is the tangent of that angle that we just drew? The same thing. Yeah, -9/2. That was nice. Oh, you have your paper and what's it saying? No turning. Okay, is that all it said for it? Yeah, okay, let me fix that for you. So sometimes they cancel out, and sometimes they might work out. Can you just look at it and guess? Well, you don't guess. No problem. Right? Is that okay? Go ahead and refresh and see if that works for you.
You want me to do the same code?
Yeah, maybe try it. Refresh and see if it works. Okay. All right. Let's look at number 6. Again, this is draw the angle that has a sine ratio of -7/6. So again, sine is opposite over hypotenuse. This is negative, so I have to draw it down here in quadrant 4. So there's my angle theta. The opposite side would be -7, and the hypotenuse would be 6. Does this work?
No.
Why doesn't it work? Okay, good. Again, this side of the triangle is 7 units long. The hypotenuse is 6. The negative doesn't matter. Yeah. So this doesn't work because the hypotenuse is too short. The hypotenuse has to be the longest side. All right. So that one is not possible. All right. So you're not going to see too many of these on Delta Math. Instead, we have ones more like this that are from the unit circle. Okay. So looking at number 7, again, we sort of just start in the inside function. What is the sine value at pi over 4? There's pi over 4 on my unit circle. Good. All right. So that's √2/2. That's from right there, √2/2. And now it says, hey, what's the arc sine? What is the angle? What angle has a sine value of √2/2? Pi over 4. Yeah, that was easy. Okay. Did these ones cancel out? Yes, they did.
What is it actually asking for?
Well, arc sine is saying what angle has that sine value of √2/2. So it's asking for that angle in radians. Sometimes it's going to cancel out, sometimes it's not. We got to think through it. Let's look at the next one here. Starting on the inside function, this says, hey, what's the cosine value at 5 pi over 6. So if you're thinking about your unit circle, 5 pi over 6 is right here. All right, what's the cosine value at that 5 pi over 6? Negative root 3 over 2 up 1/2. Yeah, so the cosine value is negative root 3 over 2. So that's the inside part. And now what's the cosine? What angle has a cosine value of negative root 3 over 2? That's 5 pi over 6.
Dude, this really checking if it's undefined.
Yeah.
Okay.
Let's look at number 9. Tangent of negative pi over 2. So on my unit circle, where's negative pi over 2?
At the bottom.
At the bottom, yeah. And so that ordered pair is 0, negative 1. How do we find the tangent? Y over x. So the tangent would be, yeah, negative 1 over 0, which is undefined. Yes. All right. Let's look down at number 11 here. And again, how she does things is just nothing like how I do things. Too much to think about. So again, starting on the inside, sine of 3 pi over 4. So again, that's unit circle stuff. So here's 1 pi over 4, 2 pi over 4. Right here is 3 pi over 4. What's the ordered pair of 3 pi over 4? Root 2 over 2. And positive root 2 over 2. Okay. So the sine at 3 pi over 4 is root 2 over 2. All right. Now, this one is different. The angle whose sine is root 2 over 2. Pi over 4. How come we couldn't just give 3 pi over 4 back again? Yeah, arc sine has to come from the right side of our unit circle. So the other angle right here also has that value of root 2 over 2. And that angle is 1 pi over 4. And that's the thing that makes this challenging, okay? When we have our inverse functions, they have restrictions, so we can only look at a part of the unit circle, okay? Let's look at, see, she doesn't have enough of these. Let's turn the page. It's not, it takes a little bit of getting used to things, I think, but, okay. So again, starting on the inside, this is the sine value at pi over 6. Pi over 6 is right here. What's that ordered pair? Good. Root 3 over 2 up 1/2. All right, and so the sine value would be 1/2. Good. All right, and now we want the cosine inverse. So what angle gives the cosine, has a cosine value of 1/2? Pi over 3. Yeah, right here on the unit circle. This would need the cosine. That's the x coordinate. So here at pi over 3, the x coordinate is 1/2. All right, so that's the one, say, hey, that's the 1/2 I need. And that comes from this angle at pi over 3. So these ones are very different. All right, let's look at number 16. The cosine at 0. What's the ordered pair here at 0? 1, 0. All right. What is the cosine of 0? 1. Okay. All right, and now arctangent. What angle has a tangent ratio of 1? Pi over 4. Good. So right here at pi over 4, our ordered pair is radical 2 over 2, comma radical 2 over 2. The tangent ratio is y over x. So when we divide those, we get 1. And so that is pi over 4. And again, arctangent has to come from this right-hand side, so we're in the right space. Okay?
So are a lot of them just pi over 4? This is like one of those random things I noticed that a lot of them are pi over 4.
Merely coincidental. There's not very many answers, though, really. I mean, when we're talking about the unit circle, there's only 17 possibilities. Maybe I don't know what it is, but not a ton of possibilities. Let's look at this one, number 18. This is a good one. 5 pi over 6 is right here. What's that ordered pair? Yeah, negative root 3 over 2 up a half. Okay. And so the cosine, that's the x-coordinate, is just negative root 3 over 2. Now our job is to figure out arcsine of that value. So now this is asking, hey, what angle has a sine ratio of negative radical 3 over 2? But first of all, we're talking about arcsine. So what side of the unit circle do we have to look on? The right-hand side. Okay, so somewhere over here. And where else do we have a negative root 3 over 2? What angle also? It's long. It's a long leg. Ooh. 5 pi. Okay, I heard 5 pi over 3. Negative pi. Okay. So 1, 2, 3, 4. Okay. 5 pi over 3 takes you all the way around, right? So 5 pi over 3, that gets us into no man's land over here. We're not allowed to travel over here on the left-hand side of our unit circle. So instead, we need to take the quick little negative angle, negative pi over 3, also has that sine value of negative root 3 over 2. That is the tricky part. We've got to get the negative angle that gets us there quicker. Okay. All right. Let's look at number 20. So, where is negative pi over 2? The bottom, okay. So, there's our negative pi over 2. That ordered pair is 0, negative 1. All right, so what is the sine value at negative pi over 2? Negative 1. Good. All right. And so now we have to say, hey, what's the arctangent? So this is saying what angle has a tangent ratio of negative 1? So first of all, we're in arctangent. Which side of the unit circle do we care about? Right side. Cosine. Okay, 7 pi over 4. All right, so again, right here, 7 pi over 4 goes all the way around. Can we do that? No, we can't. But negative pi over 4 gets us to our ordered pair, which was root 2 over 2 and negative root 2 over 2. That gives us that negative 1 ratio when we do the y over x per tangent. Okay. Does that make sense, Bertie? Yeah? Okay. So I love that you said 7 pi over 4. I love that because we've got to talk about that. So negative pi over 4. All right, good. Let me see what else we got going on here. Does that make sense? Yeah? Right. 7 pi over 4 takes us into no man's, the sinking, murky quicksand. You're not allowed to go over there. You'll die. Okay.
Good to know.
Yeah. Okay. Let's see. These are reversed a little bit. So let's look at 21. This is arcsine. So right off the bat, I'm looking at my unit circle, but what side am I focused on? The right-hand side because it's an arc function, okay? Arcsine. So this is saying, hey, what angle has a sine value of 1/2? Where do we get a 1/2 in the y coordinate?
Wait, for what?
Pi over 3. Yes, right here, pi over 3 is, oh, wait, no. Pi over 3 is 1/2. Oh, radical 3 over 2. Short leg, long leg. All right, so it's not pi over 3. Pi over 6. Pi over 6 is radical 3 over 2 up 1/2. Okay, so there it is right there. So we get pi over 6. That's our sine value of 1/2. And that's the angle right there at pi over 6. Okay, so now we have, hey, what's the cosine? What's the cosine value at pi over 6? Yeah, radical 3 over 2. That's it. Yeah. Let's look at 24. All right, so again, this is arctangent. Oh, we should maybe do 23 as well. We'll do 23 as well. All right, arctangent. Which side of the unit circle do we care about? Just the right side. Okay. And we have radical 3 for the ratio. How do we get radical 3? Yeah, right here, 1/2 radical 3 over 2. If we do the tangent ratio, it would be radical 3 over 2 divided by 1/2. And so those 2's cancel out, and that's how we get radical 3. So this angle is pi over 3. All right, and we want the cosine value at pi over 3. 1/2. Yes. Cosine is just the x-coordinate. Okay? You just got to work through it. Like, it just takes a little bit. We're doing 23 and to be done because we haven't talked about arc cosine. So starting on the inside here, my unit circle, we talked about arc cosine. What part of the unit circle do we care about? The cap is, cosine is the cap. All right. Cosine has a value of 0 at, right here, pi over 2. The cosine value is 0. All right. Now we want the sine value at pi over 2. Yeah, this one. Okay. This takes a bit of time to work through it, okay? But please ask questions. All right? You got questions for me right now? Or is really you just got to play with it for a little while?
Does it work?
No, it's still enough.